Hi everyone. In today's lesson, we're going to talk about a new factoring technique called sum and difference of cubes. Before we can do any practice problems, we actually have to review a couple of vocabulary words. Sum means to add, difference means to subtract. A perfect cube is the result of three of the same numbers or variables multiplied together. Just like a perfect square is the result of two of the same numbers or variables being multiplied together. So if we look at this list here, this is the list of all perfect cube numbers. So 1 is the first one because it's the result of 1 times 1 times 1. 8 is the next because it's the result of 2 times 2 times 2. Then 27, then 64, 125, and so on. Now, obviously this list can go on forever. I just decided to stop here. Now, if we look at the variables, x to the third is the first perfect cube variable because it's the result of x times x times x. Then we have x to the sixth. It's the result of x squared times x squared times x squared. Remember, we're adding the exponents when we multiply bases, exponents with like bases. We add 2 plus 2 plus 2 is 6. 3 plus 3 plus 3 is 9, right? X to the fourth, x to the fourth, x to the fourth. 4 plus 4 plus 4 is 12. So x to the third, x to the sixth, x to the ninth, x to the 12th, 15, 18, all of these are perfect cubes. So what do you notice about all of the exponents of the perfect cube variables, the 3, the 6, the 9, the 12? You should be saying that they're all multiples of 3. All right, so what does that mean for the cube root? Meaning, what thing times itself 3 times is x to the third, x. So what's the relationship between this cube and this? So x to the sixth and x squared. What's the relationship? X to the ninth and x to the third, x to the 12th and x to the fourth. You should be saying these perfect cubes is actually just the exponent, the original exponent, divided by 3. So the cube root is we just have to divide by 3. So if I wanted what thing times itself 3 times gives me x to the 27, I just take the 27 and divide by 3. So 27 divided by 3 is 9. So is x to the ninth times x to the ninth times x to the ninth x to the 27th? Absolutely. 9 plus 9 plus 9 is 27. So same thing, let's just say I did x to the 18th. I want to figure out what thing times itself 3 times gives me x to the 18th. Take 18 and divide it by 3, and you get 6. X to the 6th times x to the 6th times x to the 6th, right? Add the powers, 6 plus 6 plus 6 is 18. So even if I wanted to take an even more complicated one, say I had x to the 300, and I wanted to figure out what thing times itself 3 times gives me x to the 300, just divide that power by 3. So 300 divided by 3 is x to the 100. So x to the 100 times x to the 100 times x to the 100. All right, let's take a look at the rule for factoring. So this is the formula when I want to factor the sum of two cubes. A to the third is a cube, b to the third is a cube. This is how we will factor it. The difference of two cubes, if I have a subtraction sign between the two cubes, this is what it will factor out to. So let's just prove that these two formulas are actually correct. So take a minute and double distribute this right-hand side here and see if you get this left-hand side. And do the same thing over here. Double distribute or box method, whatever you prefer, that right side and see if it equals this left side. So just to show you what I want you to do, I'll do the first one with you. So say I want to multiply a plus b, so I can put the a here and the b here, with a squared negative ab and b squared. So I want to multiply this binomial by this trinomial and see if I get this. So let's do that. So we have a times a squared. That gives me a to the third. We have negative ab times a. That gives me negative a squared b. Then we multiply b squared times a, and we get ab squared. And we multiply a squared times b, and we get a squared b. We multiply negative AB times B, and we get negative AB squared. And then we multiply B squared times B, and we get B to the third. And we can combine our like terms. We'll notice that this negative A squared B and this A squared B are like terms. And then this AB squared and this negative AB squared are like terms. And what happens? They both cancel, right? They're opposites of each other. So we're just left with A to the third plus B to the third. So basically what we did, we just proved that this is the correct factorization of this sum of two cubes. Now, please feel free to do this on the right-hand side, and you should get A to the third minus B to the third. Okay, how do we put this into practice? So here are some examples. We want to factor each expression completely. So first we have to decide, do I have a sum or do I have a difference? And if you look at problem number 1, I definitely have a sum, right? I have a sum of two cubes. So we're going to use this formula here. But notice how this says A to the third plus B to the third. This says A to the third, so we're good, but this is some one number to the third power. So our first step when factoring with SOAP is that we have to rearrange it so that it looks exactly like this, where I have something to the third plus another thing to the third. So the first term, A to the third, we can keep, so it's A to the third plus some number to the third power. So you want to ask yourself, what number to the third power gives me 27? And that answer is 3. 3 to the third gives me 27. So what I've done is now this is my first term, this is my A, and this is my B, this is my second term. So we can go ahead and label this. I know it's weird, but we can go ahead and label the A with the A term and this with my B term. And this is the factorization of what it looks like. So it goes A plus B. The way I always like to do this is small parenthesis here, then larger parenthesis. And I'm actually going to write down what should go into each one. So we have A here, B here. Then we have A squared, AB, and then B squared. Don't worry so much about the signs for now. Let's just worry about getting the right variables in the right spot. So A goes here, so A, we can go ahead and put that there. Then we have B goes here, so we have 3. Then we have the A term, and we're squaring it. So take the A and square it. We're just going to get A squared. Take the A and multiply it by the B. So we have A and B. So 3 times A is 3A. And then we're going to take the last term B and square it. So we have 3 is the B term, and we square that, and that gives me 9. And then what we want to talk about for the signs so that we easily remember them is SOAP. So what does that stand for? S stands for same. O stands for opposite. A stands for always. And P stands for positive. So same, opposite, always, positive. So this first sign that we have in the original, we keep the same. So we keep it the same and we put it first, same. Then this second sign in here is always opposite of the first sign, so opposite. And then my last sign is always positive. So it goes same, opposite of this one, and then always positive. And that's it. Those are my factors. We can't factor it anymore, but this is my final answer. Now, for the second example, notice that it's a difference of two perfect cubes. And notice in the formulas, A, B, A squared, AB, B squared, the formulas are identical, except the signs are all a little bit switched, and that has a lot to do with SOAP. So let's look at this second example. We want to first write it as something cubed minus something cubed. So what thing cubed is A to the third? Just A, right? And for part 2, the second part, what number to the third power gives me 125? You should be looking at the chart on the opposite page, and you should get 5, right? 5 to the third. So now what we're going to do is we're going to say this is my A term, this is my B term. So same concept. Here is my A, here is my B. So just like we did before, small parenthesis, long parenthesis, and we're going to write down all of the things that it should be. So A squared, AB, and B squared. If you want to go ahead and put the signs in, you can. Just remember, we're following SOAP. Same, opposite, always positive. So the same sign goes in here. So same, opposite of that goes here, and then always positive. So what I did was same, opposite, always positive. And then now we're going to go ahead and put everything in. So A goes in here for A. Then we have our B, which goes here, which is 5. Then we take A and square it. So A here, we're going to square that and just make it A squared. Then we're going to multiply A and 5 together. That gives me 5A. And then I'm going to take the B term, which is 5, and then square it. So 5 squared is 25. And then this is my final answer. All right, why don't you guys try number 3 on your own, and then hit resume when you're ready for the answer. Just a hint, you want to make it as something cubed plus something cubed. So go ahead, give it a try. Okay, so your first term should have been x, and your second term should have been y. This is your A, this is your B. You need a small parenthesis and a long parenthesis. It goes A, B, A squared, AB, and then B squared. If you want to go ahead and do the signs, it's same, opposite, always positive. And in the first box, we're going to put A, which is X. The second, we're going to put B, which is Y. Here, we're going to square the first term. So we take the X and square it. That gives me X squared. Then we're going to take the next term, A and B, and multiply them together. So X and Y, that multiplies to XY. And then we're going to take the B, which is Y, and square it. So you should have gotten Y squared. And that is your final answer. Awesome. All right, let's take a look at number 4. Number 4 is a bit tricky because we have to figure out what thing cubed minus what thing cubed. So if we look at our first term, we have 125x to the third, and our second term is 27y to the third. So we know from previous examples that 5 to the third power is 125. So I can go ahead and put that in. And we know that 3 to the third is 27. So I can go ahead and put that in. But remember, we have other terms here. We have x to the third. So x, we're going to have to put in there to get x to the third. And then y, we're going to have to put in the second term to get y to the third. So basically, you have to go based off of what you have. So 5 to the third is 125. X to the third is x to the third. And then 3 to the third is 27. Y to the third is just y to the third. Perfect. So my first term, 5x, that's going to be my A. Then in my second term, I have 3y, so that's going to be my B. So we can go ahead and label this one and this one. This is my A, this is my B. So remember, small parenthesis, large parenthesis. We need A, B, A squared, AB, and B squared. You can go ahead and put your signs in. So same sign goes here, opposite, always positive. So we're going to put the A term in here and the B term in here. A is 5x, so that's going to go there. B is 3y, so that's going to go here. So we have 5x and 3y. And then we have the A term, and we're going to square it. So A has these two pieces. It has 5 and x. So we actually have to square both of them. So this actually is 25x squared. And then when we multiply A and B together for AB, we have 5 times 3, which is 15. And then x times y, which is just xy. So 15xy. And then my last term is B. I want to take B and I want to square it. So B is this whole thing. So we have to square both pieces. So 3 squared is 9, and then y squared is y squared. So final answer. Awesome. Let's look at number 5. So if you notice number 5, it's a sum. So you're probably thinking that it's a sum of 2 cubes. However, 16 is not a perfect cube, right? It's not on that list from the page from before, and neither is 2. So that should be ringing a bell that we might have to do something else. And I see I could actually do GCF. I see that I could divide both pieces by 2. So by doing so, these 2's will cancel. I'll be left with x to the third, and 16 divided by 2 is 8. So take a look at that now. I took out my GCF, and now inside my parentheses, I have a sum of 2 cubes. That's much better. So go ahead, take a minute, and factor this expression, the x to the third plus 8, by sum and difference of cubes, and then have your final answer and hit resume when you're ready for the explanation. Okay, so when you did this, you should have broken this up into x to the third plus 2 to the third. This is your a, this is your b, small parenthesis, long parenthesis. So we have a squared, ab, and b squared. My a term is x, my b term is 2. My a squared is x squared. My ab is 2x, and my b squared is 4. Same sign, opposite, always positive. And then just don't forget to bring this 2 down here, and that is your final answer. All right, so the last problem for today will be number 6. So what I'd like you to do is try 6 on your own, and then hit resume when you're ready for the answer. Just a hint on number 6 is, although they both may be perfect cubes, there may be a GCF that you want to try first. So go ahead and try that, and then hit resume when you're ready for the answer. Okay, so the GCF here is actually 8. So we have to take out a GCF of 8 first. So by doing so, we get 8x to the third minus y to the third. And what you should notice now is this inside is actually a difference of 2 perfect cubes. So when you break it up, you should have gotten 2x and y. So this is your a, this is your b. So remember, small parenthesis, long parenthesis. So we have a squared, ab, and then b squared. So my a is 2x, my b is y. When I take a, which is this whole thing, and square it, we have to square the first and square the second term. So we have 4x squared. When I multiply a and b together, 2x and y, I get 2xy. And then I have b squared. Take this y term and square it. I just get y squared. Bring my sign down. Same, opposite, always positive. And then my last but not least is bring down that 8. And this is your final answer. Awesome. All right, that's it for today. If you feel like you want to try 7, 8, 9, and 10, you absolutely can, but I will go over those in class tomorrow. If you have any questions, please jot them down. Otherwise, I will see you guys tomorrow. Have a good day.